Hello, we are from ศรีสวรรค์วิทยาคารจังหวัดน่าน School. Today we will present about production of rayon fibers from used cotton wools and tissue compared with cellulose fibers from cotton using a small-scale chemical technique. In daily life, tissue paper is widely used for cleaning various items, and a large amount is discarded as waste after use. Our group thought that repurposing used or unused tissue paper to make it useful again would help reduce waste. Similarly, cotton wool is also commonly used in everyday life. Since both tissue paper and cotton wools are made from cellulose, our group came up with the idea to take these discarded material and transform them into fibers. These fibers could then be reused for other purposes. Objectives of the experiment are: first, to produce rayon fibers from used cotton wools and used tissue paper, as well as fiber from cotton and fibers we couldn't mix in tissue and cotton wools. Second, to test the properties of these fibers by preparations of fibers from different material and testing their properties. Rayon is a semi-synthetic fiber derived from cellulose.
Part 1 experiment to produce rayon fiber. Two methods are as follows. First method. First, prepare 20 ml of saturated copper to sulfate solution, then drop concentrated ammonia solution until the solution turns to crayon green and notice precipitate. Second, isolate the precipitates from the solution and let it dry. Third, cut used cotton wools into small pieces and measure an accurate of 1 gram. Fourth, put the precipitate into cotton wools and pour ammonia solution 20 ml and stir it. Fifth, use a saline to draw out the solution and soften the tip of the saline just below the surface of the sulfuric solution. Slowly press the puncture and allow the solution to flow into the sulfuric solution until it is completely dispensed. 6. Repeat the method. But this time use tissue paper 1 gram. Use cotton wools mixed cotton each 0.5 gram. Use tissue paper mixed cotton each 0.5 gram and cotton 1 gram.
Second method. First, mix 2 gram of copper to carbonate with 1 gram of cotton wool in a small cup. Then add 50 ml of concentrated ammonia solution and stir until well mixed. Second, use a syringe to draw up the resulting solution and inject it into a petri dish containing 1 molar sulfuric acid solution. And finally, repeat the method but replace the cotton wools with used cotton wools mixed cotton each 0.5 gram. Use tissue paper mixed cotton each 0.5 gram and cotton 1 gram. This is a process for producing rayon fibers, referred to as the cupramonium rayon process. The fibers prepared by both methods are as follows. The following methods are used to test the purity of the obtained rayon fibers. First, visual inspection. During the rinsing of the fibers with water, some of the rayon fibers prepared using the second method show slight bluish coloration, while the fibers obtained from first method were completely white. Second, immersion in 0.1 molar of hydrochloric acid solution. When the rayon fibers were immersed in 0.1 molar of hydrochloric acid solution, the fibers prepared using second method turned slightly bluish, indicating the presence of residual copper 2 ions of other copper-containing compounds remaining in the fibers. The first method offers the advantage of producing fibers with higher purity than second method. In contrast, second method is more time efficient and requires fewer procedural steps. Therefore, we selected first method for rayon fiber preparation and proceed to use the resulting fibers in the subsequent experiment.
Part 2. Experiment. Testing method for the fibers. First, flammability test of rayon fibers. The prepared rayon fiber were subjected to a flammability test. All 5 types of rayon fiber ignited immediately upon exposure to flame, producing an orange flame. The combustion was rapid and continued until the fiber were completely consumed. During burning, the fiber exhibited shrinkage away from the flame and showed signs of melting. Second, dyeing test of rayon fiber. The prepared rayon fiber were dyed to evaluate their dye-active properties. After dyeing, the fiber were placed on the plastic dish and left to dye. The dye of fibers were then rinsed with water twice and subsequently placed on tissue paper to dye. Third, water absorption test of rayon fiber. To evaluate water absorption capacity, 0.1 gram of rayon fiber were wet and then soaked in water for 10 minutes. After soaking, fiber made from tissue paper and cotton wool were reweighed. Fourth, water drainage test. The fiber from the third test after being soaked in water were left to stand for another 10 minutes to evaluate water drainage. The weight lost due to water drainage was measured.
Summary and discussion of experimental result. First, to produce rayon by fibers, the cupramonium rayon process from the first method, copper to sulfate, change to copper to hydroxide, change to beta-amine copper to ion. Because the prepared fiber 1. Have a copper to hydroxide precipitation watching step. The copper to hydroxide precipitate from by adding concentrated ammonia solution to copper to sulfate. Let's filter and wash with distilled water 3 times before use. It helps remove sulfate ion excess solution and impurities that may be attached to the precursor. 2. More precise control of ammonia content. The formation of the tetraamine copper to ion complex in the wash precipitate allow better control of the ratio of copper to ion to ammonia, resulting in a more efficient cellulose dissolution reaction with less excess ammonia remaining. 3. Reduce the occurrence of side effect or insoluble substance. This method reduces the chance of occurrence of impurities such as unreacted copper carbonate, which may remain in the first method. The resulting fibers are therefore whiter and have better cellulose binding quality. Second, testing the properties of the fibers. Dye absorption. Pure cotton absorbs the most dye, followed by cotton wool blend fibers, cotton wool fibers, cotton tissue blend fibers, and tissue fibers. All fibers maintain their color when soaked in water. Water absorption. Pure cotton has the highest water absorption, followed by cotton wool fibers, cotton wool blend fibers, cotton tissue blend fibers, and tissue fibers, which absorb the least. Water drainage. Tissue fibers drainage the most water, followed by cotton tissue blended fiber, cotton wool fibers, cotton wool blend fibers, and pure cotton fibers. The use of the 5 types of rayon fibers in daily life depends on how the user chooses to utilize them. For example, if used to produce sportwear, fiber that absorb little moisture and allow quick moisture evaporation and fast drying are required. These include fibers made from tissue paper and fibers if used to produce regular clothing, which require high moisture absorption or the ability to absorb sweat from the skin for comfortable wear. Suitable fibers include pure cotton fibers, cotton blend with cotton wool, and cotton wool fibers.
This end project involved designing a small-scale chemistry experiment under the theme of green chemistry to enhance the strength of rayon fiber. Additional chemicals can be incorporated during the fiber preparation process.
Thank you for your attention.